And we're live once again. Welcome, everybody. My name is Michael Lynn, and this is the MongoDB Podcast Live. Today, we've got another fantastic episode for you. We've got a great guest lined up, and I'm really excited to dive into this conversation. Been thinking about it for quite some time. It's in the AI space, and it happens to be with a great partner of MongoDB, Gradient. Chris Chang, CEO and founder of Gradient, is going to join me for a discussion about some things happening in this space. Thank you so much for joining me today. I'm curious, as you jump into the stream, I appreciate you spending time, taking the time to join the stream. I'm curious about where you're joining from. I see Boston, Germany, Dublin, a lot of folks piling in. It's great to see folks coming into the stream. I hope you brought your questions. What are you curious about in the AI space? Are you aware of what's happening with Gradient? Accelerator blocks? Did you check out the blog article? There's a link below. You can check that out while we're waiting to begin the stream. We're going to get it right into it. We've got very little time to spend with Chris, and we're going to get into some really great stuff here. So, so we've got a lot of folks piling in. Sweden, Kashmir, beautiful. Tuning in from, Anaya. Well, hello, Anaya. Thank you so much for tuning in. It's great to see you. And we'll be in New York City together in March for a MongoDB user group in the MongoDB headquarters. So join us for that. Good to see you, Anaya. Good to see you, Majid. All right. So I think there's enough time. Folks are piling in. Everybody grab your seats, grab a drink. We're going to get right into it. I want to cover a little bit about what we're doing today. So Chris is the co-founder and CEO of Gradient. He most recently led Studio AI at Netflix and was an architect of early domain expert LLMs for content production and intelligence. Prior to joining Netflix, Chris held a variety of leadership roles at Pinterest, Opendoor, and Meta. And he started his career in finance and holds, impressively, a dual bachelor's in computer science and business and a master's in computer science from UPenn, a place I spent some time at. We'll have a chat about that. Without further ado, I'd like to bring Chris in. Chris, welcome to the show. It's great to have you on the podcast. How are you this morning?
Hello, Michael. It's good. It's a bit early today for me on the West Coast, but it's exciting to see everyone and coming in internationally. So I'm glad that
Isn't that great?
you're able to make the time work.
Yeah. I think a lot of folks from Europe, it's a little later there, but thanks so much for getting up early and joining me today for this great conversation. So I'm excited to dive right in. And really, I'm excited about the partnership between MongoDB and Gradient. Some really great stuff happening in that space. But before we get into the meat of things, maybe explain to the folks a little bit about yourself and how you got to the point where you've launched and built Gradient.
Absolutely. So I've spent some time working on core machine learning services for a number of companies. At Pinterest, I was working on their recommender systems and shopping content, early deep learning models and vision classification models for content. Working at Netflix was particularly interesting because that was at the time right before GPT-3 came out. And we were working with early transformer models like BERT and trying to adapt them for the content production lifecycle. So as you all know, Netflix spends an enormous sum of money every year on content, $16 billion a year on their own original content.
Billion with a B.
Billion. So
Incredible.
their budget for spending on content is massive. Of course, most of the content that they produce is not necessarily the best, but regardless of that, the premise for investing in AI was kind of centered around how can we make all of that spend more efficient and more valuable to our member audience. And in that creative process, one of the biggest challenges with traditional machine learning was figuring out how to augment a creative workflow, which is principally working with unstructured data and figuring out how to tune data like scripts and storyboards and things like that in a way that extrapolated patterns that could delight users. And traditional machine learning models could not pick up on patterns well enough to augment a creative work stream. But with these early transformer models, you really got to see that potential. I remember this particular oh shit moment when our data science director had come to us with one of the early tuned models that we had built for understanding script and narrative. And this was a really big deal because what they had done was basically be able to ingest the script and map out the story structure and understand really the underlying elements of the story from that script itself. And it became really obvious then that transformer models and the ability to take in unstructured data and extrapolate patterns and build out information in a way that was consumable for humans, that could really be powerful, especially in a world where most of our data is 95% of our data is unstructured, and how many people are we spending countless resources on trying to just munge that data into something that is a consumable format for us to manipulate. So that was really a moment where it became really clear that this could be the future for business. It could completely change the way that we think about creating anything, including movies. And there was an opportunity for us to build a business around this. So that's really when we started. That was the kernel that really started the
Mhm.
path to make Gradient.
Yeah, yeah. And it's been how long? How long have you been building Gradient?
About a year and a half now. So it's been a bit of time. Um, and it's it's been an incredible explosion of opportunity and also developments in the AI space ever since OpenAI really opened the door with 3.5 and ChatGPT. So
Yeah.
uh, incredible time to be in this space.
Oh, yeah, absolutely. I mean, it's almost scary how fast, like the exponential, explosive growth of development. And before before we went live, we were talking a little bit about like how AI development, well, computer and software development in general, kind of replicates the the human mind and the way that we think. And the next logical leaps, I mean, we're getting so close to duplicating human intelligence. It's almost like artificial intelligence is really a bad it's not an appropriate name. It's really human intelligence. And I'm curious about your thoughts in that space. Like, do you think we're replicating human intelligence in what we're building?
So it's really interesting. So if you actually look back on the history of deep learning and the underlying structure for how these models work, uh, there's this fundamental primitive called a perceptron, which is
Mhm.
basically a mimicking the neural link or synapse, where you are modeling creating a synapse in a digital environment. So the synapses are basically you have some sort of signal. You're setting some sort of threshold by which that signal, that electrical signal, then translates into that synapse firing. Um, that is the fundamental primitive for neural networks. And
Mhm.
if you just think about it from that perspective, you are literally taking a biological innovation, which is neurons and neural synapses, and creating that in a digital environment. Um,
Mhm.
and so, if you actually think about how humans have come to understand how to manipulate even the most fundamental neural networks, it has never really come from a perspective of deeply understanding how that neural network learned beyond the mathematical principles. The
Mhm.
way that they've been developed has been treating it as a black box and building an experimental approach. So you don't exactly know what you're going to get out of it, but you think that if you give this neural net some sort of signal, some sort of input, a feature that you've developed, you suspect that it will perform better, and then you have to go and experimentally validate that. And afterwards, you get side effects. So it's not really easy to figure out what happens in that process. Sometimes the model learns something that you didn't really expect, and then you have to go figure out why.
Mhm.
That problem of figuring out how to get interpretable, explainable results in a deep learning world translates into the challenges around getting interpretable and um, observable results for LLMs. So it's interesting because I think fundamentally you can't understand what happened with an LLM because it is as challenging as understanding why a human uh, learned something that was unexpected when you were trying to train them for the job. And
Mhm.
the only way you can do so is by asking it. And the problem with LLMs is that if you ask it, it has no real like retention or memory for why it had conducted an action. The justification is a separate uh, answer. It's a separate prompt, right? So it doesn't actually is not really able to actually go back and introspect, which is interesting. But in general, your question around like are we actually getting closer to human intelligence or what it is? It's a form of intelligence for sure. It proxies human intelligence. I
Mhm.
would say it's something that's slightly different from human intelligence because humans have not crammed the world's data into their brains. So, uh, intrinsically, the capability of a model to understand certain things is fundamentally different from a single human. But I think what is happening, it is learning to model and understand how to represent what it observes as a black box, which is humans, through
Mm.
the dialogue and information transfer that we are generating, which is text, and increasingly, spatial and visual and audio
Mhm.
information as well. So as you get to a more and more richly multimodal experience, you could get to a world where the model not only is able to understand and approximate human intelligence, but it's actually transcending that because
Mhm.
how much information in the world is generated by non-humans. You can just imagine the kind of possibilities when you start to think about, I have this superhuman brain that I am now feeding all sorts of information that humans cannot no longer process. What can happen there? Kind of interesting
Mm.
problem
Yeah.
or conceptual thought.
Oh, just fascinating space. I love spending time on that. It has me thinking about, and we're going to get to gradient and what that looks like and how it can save you, the developer, time. But I want to explore one more little nugget of thought that came to me prior to jumping on stage today. It's the concept of intuition, and I'm rereading Daniel Kahneman's Thinking Fast and Slow, and this concept of System One and System Two, where System One is this very fast, almost intuition, and System Two is this methodical approach to knowledge farming. And I'm wondering, is the development of LLMs and the training of specific models, is that akin to intuition? Are we building intuition into artificial intelligence through that?
That's an interesting question. I think intuition. So you know, system one, system two processes still fundamentally rely on the same foundational architecture, which is the human brain, right?
Mhm.
And so it's still using the same hardware. But I think there's a couple things that happen differently between system one and system two. And there's certain chemical influences that lead system one to make certain judgments that are different from system two. And there's a couple things to that. One is that um, emotional drive heavily influences the way that we interpret and make snap judgments, right? System one is really
Mhm.
a way for us to process huge amounts of information quickly without expending additional computational power.
Mhm.
The concept of introducing emotions, aka biases, into the brain uh, is done based off of external stimuli and other almost like semi-synaptic responses. So you get slighted a bunch by a bunch of people, you start to feel angry, you start to see things with a different color because
Mhm.
that whatever chemicals are happening when you feel anger, it's influencing how you perceive the world. That concept is really interesting because I don't think we've actually applied that emotional element to an LLM, which is basically
Yeah.
just to say, hey, let's take the certain neural pathways that would be triggered when you see something, and let's amp that up. There's actually a research paper on something called representation engineering that tries to mimic that. So what I did
Mm.
was basically they modeled out the neural pathways for the
Yeah.
LLM, and they took certain emotions, so like anger, happiness, sadness, and content that would represent that, and they fed it through an LLM, and they kind of mapped out which areas of the LLM are firing more frequently when that kind of content happens. They took that, they turned it into a LoRa adapter, which is basically just um, a way to introduce or manipulate model weights, and they basically use that to create some semblance of emotion, which is interesting because now you can actually increase or decrease the level of quote unquote anger that the LLM is representing. I think it's starting to get closer to working towards that like kind of system one process. The way I think
Yeah.
about system two, which is self reflection and reasoning and things like that, those are actually in my head they're like internally multi-prompt chains. So you're internally asking yourself, does that make sense? What are the other things I should be taking into consideration? Am I being objective here? How do I evaluate this more critically, et cetera, et cetera?
Mhm.
You're trying to basically then take that output from maybe system one and then kind of introspect on it a little bit more. So it's interesting because I think there are actually techniques that are starting to kind of indicate similarities in that regard.
Yeah. Yeah. So essentially, what we're talking about is how AI development mimics or replicates human intelligence. And I think that's a great transition to what you've built with Gradient. And it's in the RAG space, retrieval augmented generation. And maybe give the folks a little bit of an overview of what Gradient's accelerator blocks are about, and then we'll lead into maybe taking a look at the product.
Yeah, so Gradient from the ground up is designed for enterprise workloads. Um, and what is the foundational component of enterprise workloads? It's working with unstructured and semi-structured data and manipulating it or creating insights out of that so that you can perform or produce an experience for downstream customers in a way that is delightful. And so uh, I mentioned before that 95% of the world's data is unstructured, semi-structured, and we're only utilizing a small percentage of that. And on top of that, enterprises are dedicating huge amounts of resources to trying to wrangle that data, to make sense of it, to process it, and manage it in a way that you can then deliver that necessary experience. So that was actually the foundational reason for why we were excited to work with MongoDB and build on MongoDB Atlas, because um, MongoDB is the core to that enterprise workload that is designed to help enterprises model and run on unstructured and semi-structured data. Now,
Mhm.
when we talk about workloads, there's a lot of existing primitives within that workload or workflow that need to be tuned well. So, for example, almost every kind of document processing workload involves a form of data extraction and data cleaning and data transformation on that loosely structured data. And what we've done is we've taken LLMs, which is a very open-ended experience, and we've tuned them for those particular workloads so that you can plug and play them and make a document processing workload built quite smoothly without having to worry about figuring out how to tune the LLM to be better for that particular step in the process.
Mhm.
Um, and RAG is a critical aspect of that because to process data, you need access to data. You either need access to rules to process that data, or you need access to the underlying data itself, and use RAGs as almost like a temporary cache to manipulate that data.
Mhm.
So we've built all of this simplification on top of MongoDB Atlas. We've made it possible for you to essentially drag and drop data directly into a RAG so that you can get started very quickly and be able to experiment with the underlying RAG plus document processing workload to get to the production setting that you need to. And it's all the process for setting up the RAG is all powered by Llama Index, which is naturally
Mhm.
one of the best frameworks um, for building out and customizing your RAG in an increasingly sophisticated way. So
Mm. Yeah. So I'm excited to see the platform, and I'm thinking about it in terms of like who's going to be using this. There are software developers that are interested in developing AI focused apps, is there a specific industry or a specific use case that would benefit from Gradient's approach?
Yeah, so we particularly specialize with security sensitive domains, areas, domains that have a lot more contextual knowledge and challenges that make it hard to just use something like OpenAI independently. And so we specialize in financial services and healthcare, but we also work with a number of other enterprises that are looking to further augment their AI workloads.
Hmm. Yeah. So there's a question about differentiation from other products, other vector databases, and I know I would address this in saying it's about proximity to your data elements. Like if you're building an application and you need to leverage vector embeddings, why not store those vector embeddings in a database that is flexible and is really well tuned to store unstructured and semi-structured data? But how would you approach that question?
So for us, one of the natural reasons why we built on top of MongoDB is that the underlying document model is is the fundamental primitive that should be used when you're thinking about building out anything involving giving an LLM access to data. Um, and so if you just think about the trade-offs between transactional databases and document-based models, uh, originally the premise for document-based models is that it's much easier to scale out horizontally. Now that has changed a lot with um, Postgres and other much more scalable databases, but fundamentally that was the original premise. But then separately, it's it is the foundational way that you think about building and manipulating data for applications. And if it is also the fundamental way that you should be thinking about manipulating data for an LLM, it is only natural to then extend that. If your data is already in MongoDB,
Hmm.
why would you move it somewhere else to build your AI workload? Essentially, it,
Yeah.
it it makes sense for it to be in one place, and so this is why we opted to start with the MongoDB approach because a number of our developers were already using MongoDB, so
Hmm.
we had already talked to them, and the common feedback that we got was, you know, can you just make it work on top of MongoDB, and then eventually be able to have a much deeper integration where you can just you know uh, one click set up your RAG based off of from your application
Hmm.
database. That is the eventual dream. And so to me, it's really more of like a first step to getting to that very, very deep integrated partnership.
Yeah. Yeah. That's a great answer. Thanks for that. So, folks joining the stream, watching, we're talking with Chris Chang, founder and CEO of Gradient. Gradient's just released a very cool feature called Accelerator Blocks. I'm excited to see it. Chris, do you want to maybe take us on a little tour of the product?
Yeah, sure. I'll just show you real quick what that looks like. So our product is fundamentally designed for developers, and
Mhm.
it's we have a UI interface that is very easy to use without having to figure out how to configure anything. The UI is designed to make it possible for you to go from 0 to 80 exceptionally quickly. At the same time, we've also got an API experience that allows you to further express customization and then embed the experience directly into your product. The API is not particularly uh, uh, fun to show on a live stream. So I'm going to show you
Right.
the UI first,
Okay.
and then talk a little bit more about what the rest looks like.
So we'll need you to share your screen, hit that present
Absolutely.
button. Yeah.
All right, are you able to see this?
Perfect. We are now. Yeah.
Okay, so what we've done is wrap RAG creation all into into a single spot, and into a single experience, so that you don't have to worry about anything because it's already auto optimized for your particular use cases. So
Hmm.
let me show you what it looks like to create. Let's say that we're working in financial services and we're trying to set up a quick RAG collection process, so and be able to query earnings reports for investors, or set up a service that can do that easily.
Great use case.
So,
Yeah.
so the act of creating a RAG on our service is as easy as just selecting the data that you want to load and uploading it. Everything
Mm.
else is handled for you behind the scenes. So it doesn't really matter what format that you have. We go and process and parse this automatically. We identify what kind of data that is and then intelligently chunk it behind the scenes. And then we use our own tuned embeddings model to create the vectors and then store those in MongoDB Atlas so that you don't have to do anything other than identify the data source. Now, we're also
Yes.
working on extending this. So, audio data, transcription data will also be possible for you to add to this collection. So it basically becomes more of a multimodal sources. You'll be able to add images and video, et cetera, over time, so that you can really focus more on putting your rich unstructured data into a service and be able to work with it very quickly. So I just uploaded a couple documents. You can see how fast that was. And we'll actually use our tuned question and answer model. So this is a Llama 2 70B model that we further instruction tuned to be able to answer questions on documents more accurately and more reliably. And so you don't have to do that work, because many times, one of the core workloads that you do have is being able to ask a question on a document and get some sort of response out of that. KYC compliance, for example,
Mhm.
the
Yeah.
entire process is just asking questions on a document. It's, the 20, 30 question survey essentially that you need to be able to conduct. So Tesla's GPU plans. Let's just ask a question. I'm going to submit this. And what now this document workflow is doing is it's taking that RAG, it's attaching it to the model, and it's executing that all on our infrastructure. You are just focusing on the data and getting the output that you need. And we've
Mm.
got a bit of a debug view here, but here is the response that they had based off of the earnings transcript and the 10K that I had uploaded. It's able to summarize very quickly, and you can actually debug and see what are the sources of data that this is a long block of text, but that's the original data that it was using to understand that. So very,
Yeah.
very easy, very fast to do that. You can also then further tune these models and create your own models. For example, in this world, you have a number of specially tuned models that you can then plug and play into your accelerator blocks or plug into general inference as well. So we support going, from the highest level, easiest abstraction, these predefined accelerator blocks, and allow you to go into increasing levels of complexity. You're also able to, fine tune your embeddings model, et cetera, to get to that 100% performance that you want for an enterprise production system.
Yeah. Incredibly fast. I mean, just the ability to go from zero to a RAG based, finely tuned uh, application, basically, and be able to ask it questions based on that on the fine tuning. So you're leveraging MongoDB behind the scenes. The process of uploading documents that will train the RAG, that's behind the scenes. It's leveraging a MongoDB Atlas database. It's creating the vector embeddings, putting it into a database. What does the partnership look like beyond leveraging Gradient and leveraging Atlas? Once those vectors, those embeddings are created, as an application developer, do I have access to that database and collection?
Yes, you do have access to that database and collection. You can access it via our own API. Over the long term, our goal is to get to a deeper integration so that you don't even need to export that data to us. So right now, the process is you're kind of extracting that data and uploading it into our own service, and then we're putting it back into Mongo. That's an inefficient process. Ideally, within Mongo, you can say, I want to create a RAG based off of this. You click a button, the RAG is created, the embeddings model is tuned based off that data automatically, and then now
Mhm.
suddenly you have access to that vector store immediately within your MongoDB ecosystem. The gravity of data is a foundational principle that we are very cognizant of, which is,
Mhm.
fundamentally that if your data is already in a single place, it doesn't really make sense to move it out to do other processes. Other processes should come and build on top of that core data set. And we are excited and looking forward to moving closer towards that core product integration, because that is really for us the way that creates the best value and convenience for the developers that are trying to build or transition existing business workloads into AI native workloads.
Mm-hmm. Okay, so what we looked at, pretty compelling. It involves leveraging it involves leveraging the Gradient UI, which seems dead simple to use. But I imagine, and you mentioned this briefly, but I imagine there's programmatic access to this functionality. So as a developer, how does Gradient surface to me? Is it just through the UI, or am I able to do some of these things through an API?
So we've got an API, SDK, CLI, everything under the sun. We've got a JavaScript and Python SDK that makes it possible for you to access these and deploy and embed inference with the RAG built in, all within a single API call. The things that we're working on right now actively are making it possible for you to more flexibly configure that RAG. So after you've created the RAG, you should be able to further customize the settings for chunking logic and tune that embeddings model, things like that. That's all done via the API. The UI is more of a quick way for you to test and iterate. The API is where you go a little bit deeper and really start to focus more on the production settings.
Yeah. So there's a question from Arjun Joshi. This is great and quick. Does it have any inference with other RAGs?
Yeah. So the answer is you would have to do that separately. So we have inference for LLMs. You would have to then go and find a way to add your other RAG context into that inference call. So the trade-off to that is that you don't get to use that convenient RAG setup that is built on top of MongoDB. If you have an existing RAG, I would recommend that you move it over and set it up on top of Gradients. It just makes it a lot more convenient and easy for you, because the way that we do it is you just add the RAG ID to the API call for inference. And you don't have to do anything other than add the RAG ID and where you want to inject the kind of document information. So we do simplify quite a bit of it for you, but we can't do it if you don't have the RAG on our service.
Yeah. Okay. So there was another question that I think we answered. If I want to embed it in my application's API, I imagine the question is there's an API.
There's an API. The API is very easy to use. So all the accelerator blocks are accessible via API, and all the low-level stuff in terms of fine-tuning and creating more customization, all of that is available via API. The API is our foundation. The UI is a good presentation layer and good for rapid iteration.
Yeah, yeah. And a great job on the UI. It's really looks like it's super easy to use. So folks joining or watching the stream, please feel free to put your questions in the comments. We'll try to get to those. Chris, what's next? Where are we going from here?
The industry or Gradient?
Let's start with Gradient.
I guess the kind of one and the same, because that would be my responsibility. So
yeah.
Let me tell you how I'm thinking about the next year and the next 2 years. I think that very easy to identify pattern right now is that enterprises are curious about AI, but are unable to get AI to work in production. Almost everyone is prototyping and working with these systems today. But it is very challenging to get these systems into production. And this is one of the reasons why we built out these accelerator blocks, started to focus more on that ease of getting from 0 to 80, because I think a lot of folks that are testing today, you can get a prototype up and running on OpenAI extremely quickly. And then when you start to get into the production considerations, can I get it into my own VPC? How do I make sure that the data is not moving outside of my environment? How do I make sure that I have the right security protocols in place? How do I make sure that the answers are much more robust, and I have observability across all of that? It becomes challenging. And uh, our foundational bet is that it needs to be a lot easier. It needs to be substantially easier to get AI applications into production, which is why we've built all of this stuff out, the accelerator blocks, the foundational models, to get you in a setting where you're realizing business value from your AI investments now.
Mm.
That is not the case now. And over the next 1 to 2 years, our goal is to make it, exceptionally obvious how to get AI into production and how to get that into a world where you are able to reason about the value that you're getting from your AI investments.
Yeah.
My concern is that the industry is not able to realize this quickly enough. Um, there aren't that many companies focused on getting real ROI out of AI for enterprises today. There's a lot of companies that are building quite innovative technologies that are subsidizing inference and making it faster and cheaper, but the act of figuring out how to make the AI work is still the biggest challenge today. One of the core problems is getting the production data, the application data, accessible to the AI. And the other problem is getting the AI quality to be high enough for that production setting. So that's why
Yeah.
working with Mongo, it's exciting because you guys have the application data. It will be easier to get that into a consumable state because it already is modeled in the right way.
Yeah. So there's a blog article that's been written talking about accelerator blocks and the partnership between MongoDB and Gradient. I've got the link on the screen. It's also in the notes below the description of the live stream. I'd encourage folks to check that out. It explains in great detail what's happening with the product development at Gradient. Chris, I'm curious about hallucinations. Is Gradient doing anything to minimize hallucinations?
Oh, absolutely. Hallucinations is one of the biggest problems um, uh, for AI development in production. And the reason why that matters is in an enterprise setting, you absolutely do not want to have hallucinations if you're trying to answer a question for a patient on medical benefits.
Yeah.
You don't want to have hallucinations if you're trying to do KYC compliance. You ask the question, who is the CEO from this document, and the model makes it up. That's a bad sign. So yeah, there's a number of things that we're working on to make hallucinations a thing of the past. One is that um, tuning these models, instruction tuning these models, and um, making them more apparently uh, honest and reflective on the underlying source of data is an important aspect. The model does not know to not make up data it doesn't have unless you train it to not do that, right? It just doesn't know because the goal of the model is to create an output that is probabilistically representative of what an output should look like. So if it doesn't know, and all of your training data says this is an answer, it's just going to say an answer because that's what you've trained it on. So, for these accelerator blocks, for our domain specific models, we invested really heavily on adding training, injecting additional training data to make these models more hallucination resistant, to really kind of enforce the fact that it should say it doesn't know, or um, or not even reference any sort of information outside of the provided data. The second thing is that the retrieval augmented generation process is intended to also help mitigate that hallucination because uh, providing models the correct context is the first step to getting it to not hallucinate, right?
Mhm.
And the third thing that we're doing is as a developer, you shouldn't have to think about setting up that. I mean, when we talk about the system one, system two processes, right now everyone is basically thinking of prompting as a single forward pass. I'm going to give you a prompt, I'm going to get an output. And the problem with that approach is that you introduce no possibility for reflection. And reflection and introspection is a great way to add more rigor to mitigating the hallucination process if there is no available data to answer a question on. And so we're setting up AI systems behind the scenes to help automatically do that, so that when you ask a question, you don't have to, remember to remind the model to reflect on itself. It's already doing it. Um,
Mm.
the kind of like multi-chain prompting and leveraging different models to evaluate the outputs is an effective strategy for mitigating the hallucination or inaccuracies, and that's really why a number of enterprises have worked with us to productionize AI into their systems, because our hallucination rates are substantially lower than if you were to use comparable services. So
Yes, this is really live, architect. A comment from
we're
the
real
YouTube stream.
people.
This
Yes.
we are real. We're in the moment. We are not AI.
Actually,
Although we're getting,
If it was AI generated, it technically would be live too. It's just, we're
that's
not
true.
humans.
Right.
So
um, so you answer the question about what's next for Gradient, but I'm curious. Like, you're spending so much time thinking in this space. What do you think's next for AI? There's been this explosive growth, and like people are, it's still shock and awe with what's capable. What is the next thing that's going to shock and awe?
I think one of the biggest things is getting the models to actually have reasoning capabilities, logic and
Mm,
reasoning. That's the foundational element that is missing for the model to be able to do those, much more rigorous system two processes, and be able to take on higher level subjective decision making that you traditionally rely on humans for, in terms of like the low level work that people nobody wants to do, in terms of, customers complaining, what do I do to figure out how to escalate this process? I would rather just move on and, work with this other customer. That kind of work can all be automated with AI once you have that fundamental logic and reasoning. There's actually an interesting concept that I don't think many people actually talk about, which is this concept called mental rotation. Are you familiar with it?
I am not.
So, um, as humans grow up, I have a 1-year-old, so I'm thinking about this right now.
Mm,
Um, as humans grow up in the early stages, one of the first things that they do develop is the ability to start mapping out objects from multiple positions without having to see what that looks like. So here's an
mm,
example. Here's a mug. I can now imagine, if I rotate I can't really see. If I rotate the mug, that is called mental rotation if I'm doing that in my brain, right?
mhm,
Now, one of the most challenging things if you are blind, if you're born blind, is that you're unable to visualize that. So you're actually unable to simulate how objects rotate, and you're not able to then have what we define as spatial reasoning. Your spatial reasoning is actually materially worse if you are born blind. Um,
mm.
Spatial reasoning is one of the core components to having efficient learning, and to be able to have higher level reasoning capabilities that are uh, uh, easier to grok and adapt for a model,
Yeah.
or model being a brain.
Mhm,
Now, how does that apply to this world? Well, you can now imagine if an LLM functionally is blind because it is only seeing the world's text, that concept of rotation is not possible, right? It visualize because it's never learned what visualization looks like. Um, Moving models to multimodal unlocks all sorts of potential, because not only do you have access to way more data that is much, much more rich and dense, but at the same time, you're able to unlock these mental capacities that are more efficient for these models to learn at lower complexity. You don't need to put in as much energy
mm,
into training the model for learning these things. So I think what you're going to see is, as these multimodal models uh, become more prominent and larger parameter count, you're going to see a much more rich set of capabilities coming out of these models. The second thing is that mixture of experts, and thinking of LLMs as or LMs as multi-agent systems will be the next step as well. So not only will you start to think about much more rich input and processing for these models, but actually creating systems of models to solve a problem. That is also the next step. Why? Humans are not fundamentally a single forward pass brain. We have many different subspecialized components working together in tandem simultaneously, right?
Mhm.
That is really where mixture of experts and AI systems start to come into play as inference becomes cheaper, as sophistication around training these mixture of expert models becomes cheap, because becomes higher and higher. I think you're going to see the world move towards that system based approach uh, over the next couple of years as well. Um, I don't think that there is going to be another oh shit moment in the same way that GPT-3, GPT 3.5, and ChatGPT
Mhm.
um, came out, because I think it's already apparent that it's possible. And now we're just figuring out how to get it to the point where it can do the stuff that we imagined. That's my general opinion. Just in the
Yeah.
same way that, self-driving felt possible the day that Tesla released autopilot v0. It was a
Mm.
little scary at first. It doesn't quite know what's going on, and suddenly it just swerves. But you can feel the future, right? And it's it's taken, I don't know, 8, 9 years already, and we're still kind of in a place where it's almost there. It's going to be very similar with these kinds of transformer based models. Also, another thing to add, moving beyond the transformer architecture, really interesting
Mhm.
problem. So there's new architectures like Mamba, which allows you to increase the prompt length and context length without having a quadratic increase in your compute resources. It's actually linear. That means it's
Mhm.
substantially more optimal for exceptionally long context length sequencing things like DNA sequencing or chemical synthesis, time series forecasting. There's all sorts of new applications of these kinds of transformer like approaches
Mm.
for processing unstructured data. I think you're also going to see that happen more as well.
Yeah.
Transformers today, we always think about generative use cases, talking, chatbots, marketing, content creation. Um, but I think if you just transform the concepts of language and unstructured data processing to a broader set of tasks, you can see all sorts of industries will be transformed, right? Because the whole act of structuring data, for example, in 5 to 10 years may not even be a thing, because you may not even need to worry about structuring the data, which is literally just a heuristic to
Mhm.
help humans figure out how to analyze and process, if you have these AI systems as intermediaries. So um, yeah, future is really exciting. I think there's a lot of things that are coming to play, but it'll look very similar to what we've already seen, just applied in different ways,
Mhm.
and definitely incrementally better over the next 1 to 2 years.
Yeah. Yeah, I'm curious about the the Moore's law, you know, transforming from quadratic to linear, what that endpoint looks like. But you mentioned a couple of things, and it is exciting. The future is super exciting. But what scares you? What are you concerned about in the AI space?
If you ever read anything that Jan LeCun sends out,
I haven't. Yeah.
um, I think it's exceptionally fun to be an AI doomsaver, because one, there's no cost to being a doomsayer. If you're wrong, nobody's going to say you're an idiot. And two, it grabs headlines, right? So you get the
Yeah.
attention with none of the downside risk. Um, the reality is that AI is not very scary. it's it's
Mm.
it's not really able to do anything unless you tell it to. And so more of the scary part is maybe getting it into the wrong hands. That's one thing.
Yeah.
But it's impossible to imagine a world where you can successfully isolate people from accessing AI without having other consequences. You censorship does have costs.
Mm.
So um, I think you have to accept the world as everyone's going to have access to AI over time, and your goal is to outsmart competitors, outsmart enemies, etc., in a way that doesn't restrict your own population from benefiting from this stuff. Um, My worry is that there is a heavily reactionary approach to AI where it becomes so heavily regulated that inevitably the only winners from AI are the ones that are already winning with AI, aka big corporations that have large amounts of funds to manage regulatory processes and benefit from isolation of AI. If you look at the companies that are actually proponents for holding back AI development, it is kind of coincidentally people who would benefit from that particular process as well. So it is important to kind of acknowledge that, say, hey, maybe that isn't the right way to think about things. We should have a debate about this, but don't impede the progress. The AI can't even freaking drive the car, right? It's like the AI can't even process data. You can't even process a document right now. Like, let's not mince words. Like, the AI is not going to take over the world yet. It can't even freaking figure out how to take a document and summarize it properly.
What if it gets loose?
If it gets, and it's like, oh, it's like, this is gonna go run, like, oh, I have a super intelligent AI that's like extracting PDFs. If it gets loose, like, all the PDFs will be converted. What will people do? I have no idea. My whole life is ruined. And it's like,
Right?
that's not the thing. Like, you got to think forward. Like, that's not the thing that people want to do, first of all. So yeah, that's my concern. I know there's real concerns around using AI responsibly, but it's just so fun to overplay that I don't know. It's easy to end up hurting people in the process. The people that shouldn't be hurt about it, hurt from it.
I agree. We're swiftly coming up on time, and I greatly appreciate you taking the time. And I want to thank the viewers for joining us today. I want to remind folks that there's some accompanying resources. They're all linked below, and we have some direct links. There's a great blog article that talks about Gradient's latest developments. We covered some of that today. It's covered in depth in the blog article linked on the screen now, mdb.link/gradient. Chris, is there anything else you'd like to share with the audience before we wrap up?
I've had a great conversation. If anyone does have questions or want to chat, feel free to just grab me on LinkedIn and through the links below. Happy to further the conversation. It's been really fun to talk about the future of AI, MongoDB's role in this, Gradient's role in this. I'm excited to see what the future looks like. Honestly, this is probably one of the big transformative moments for the industry as a whole. And having seen Web 2.0 play out over the last 10 years, I am personally very excited to be at the beginning of this movement, because I think this is actually going to be much more embedded, much more transformative, faster than Web 2.0 was. So get ready for a lot of change.
I'm ready. Chris, thanks once again, and thanks to everybody viewing. Greatly appreciate you taking the time to listen in today.
Yeah, thanks all. And thank you, Michael, for the chat. It was a fun conversation.
Yeah, it was a great conversation. Thank you.
All right. See you all.